We are back to continue with our exercise where we left off from our last video. I've had some time to think about it. It's a bit of a challenging one, but actually just that little break helped. Don't get stuck into a coder's block where you really get fixated on a problem. Move on to something else, take a break, come back to it. Even getting the solution is not always a terrible idea. Like, don't feel bad, because sometimes, remember, we're learning. So part of learning is getting things wrong and seeing where you go wrong. So let me switch over and share my screen. Okay, so what the problem I was having, let me just read the question again. We need to check, right, if a word is in a list. Now, we can use the in operator, but it can be so because it searches through the words in order. And I imagine if the word list is like 100,000 words, it's going to take forever. So there's a method we can use, which is what we're trying to figure out, where because the words are in alphabetical order, we can speed things up with a bisection search, also known as a binary search, which is similar to what you can do when you look up a word in the dictionary. You start in the middle and you check to see whether the word you are looking for comes before the word in the middle of the list. If so, you search the first half of the list. Otherwise, you search the other half. Either way, you cut the remaining search space in half. So if the word list has 113,809 words, it will take about 17 steps to find the word or conclude that it's not there. So we want to write a function called inBisect that takes a sorted list and a targeted value and returns true if the word is in the list and false if it's not. So I think I have an idea of how we're going to do this, but in my mind, it's going to require two functions and then calling a function within a function. I've done that on Java. It can be tricky, but I'm not sure how it will work on Python. So this is unscripted. If you're new to the channel, this is unscripted, unedited learning. I'm here to learn with you and share our learning experience together. So it might not actually work out, but I want to at least try. So the first function, or the first part of it, right, we want to get in a list. I would like to, first of all, get the middle index of the list, and then, which is this code over here, and then I would like to sort it, okay, which is this over here, but actually we should say list.sort. So let's just clarify here. We're going to say in bisect, we're going to take our list, which is, in this case, it's going to be dictionary. Then to work out what the middle element is, we are going to use this variable here. So middle equals length of the list divided by 2. And then I would like to return middle. Actually, we don't need to return middle. And then we also need to sort our list in alphabetical order. So that's what the first function needs to do. I don't know if we can do it here, but we can say before, so this is the problem I was going to have. So for word in list. So this is why I'm still struggling, because we want to be able to run our function just by putting in the word in our argument, right? So actually we don't want to just thinking within this function, what we want is we want to return, right, list and whatever the middle element is. Okay, so we want to return the middle element value. So I'm going to, I don't feel like deleting this. Let me cut it and then we can just delete it. So let's see what happens if we run our code. So it's returning giraffe. Now remember 1, 2, 3, 4. Let's just print list. Okay. So we can see what it looks like in alphabetical order. And you can see the middle will be number 4 because this has got 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. So the fourth is 1, 1, 2, 3, 4. Remember, it's actually gonna, because this is an index value, so we start from 0. So 0, 1, 2, 3, 4. So it gives us giraffe. So we know it's working. So the way I was thinking this function would work, right? We've basically bisected or divided our list into 2. And remember, it can be any list. Now what we want to do is actually have now a second function where we check a word. So I'm going to call it check word. And now we can actually have an argument where we can put in any word just by running our check word function. But now we need to use this function here within our function here. Not sure how we're going to quite get to that, but if word in dictionary, okay, no, it's for word in dictionary. Is it for? And do we want, we're not iterating, we're just checking. So, whoopsie, F11. Now, what I want to do is the way I thought we can check. So now we want to divide our list into 2, which is what we've done in our code here. We return our middle element, which is in this case, giraffe, okay? We need to see now, how are we going to tell if the word is before or after giraffe? So, I thought we could use sort and then see if the list changes, but I think we might actually run into complications. We can try that, but I actually have another idea now using our element number. I think that seems actually quite simple. How do we check the index number? Yeah, without having to go through all our notes all over again. How do I check index number of an element in Python? Index method. So you would say x dot index and then whatever word you're looking for. So that makes sense. That makes sense. So we in here now we're bringing in our word. X dot index equals, let's just see here, return index value of whatever answer we get in bisect. What if we said index of list? Do you think it's not going to work? Which means we have to do it here. We would Would this work if we said list dot sort? We'll find out, I guess. Hold on, I think I'm being silly now. I want to not necessarily return the middle value. I want to return the index of the middle value. That's what I need. So it's going to return giraffe. Now, how do I convert that into now an index? That output. Would I say list.index in bisect? But list is not defined. What if I said return list.index in bisect? Is it going to be a problem? I don't think so. Yeah, function in bisect not is not in list. So the way we had it before was return. How did I have it? Yeah, return list middle. So this is in right, we could say index of I am being silly because this is gonna return, if I just say return middle, it'll tell me it's 4. I'm just complicating it for no reason. Was never closed. What was never closed? Sorry. Print. Yeah, so it's going to return 4. So it actually doesn't matter what that is. I think comparing two lists to see if it gets resorted or not to determine if it's in alphabetical order is just way too complicated. So I'm going to try this method. So now we are going to now that we got a value here, but I don't know how I'm going to compare the indexes. But anyway, now we're going to have our check word function where we can basically put in, like I said, any word. And from that, we can then use this function here. We can add words and it will just adjust it automatically. Now, I think we still need to sort our list. To, I guess, save the, because if we don't sort our list, what's the point of splitting it in half? Is my logic right? It is right, but we absolutely must sort our list. Okay, so this is the problem, because now this is the problem, which means the way I had it before was correct. You see here, if I do list dot sort here, again, it's a problem because we're putting in word there, not our list. So we have to return our list middle. Okay. And then from there, let's just delete that again. But I can see this is still going to be a problem, because how are we going to ensure it stays in alphabetical order? So maybe it is just one function, but it can't be, because we want to work with a certain word. So is there a way of maybe doing a new list? But I don't think we can. I don't think with dot sort it will return a non-value, because if I say in order, okay, equals list dot sort, we can try return in order, and let's see again if it returns none. You know what? What if we just put 2 arguments instead of 1? List word. You see, I am complicating. Unused. But this is how we learn. Say hello to Ginger. This cat's like my little soulmate. He follows me around. He's the most attached to me out of all of them. So we are going to use 2 arguments, and word is where we will perhaps yes, I know it's unused. What if we just make it empty for now? Stop that nonsense. Sorry. Word equals. We leave it empty. Yeah, now it's fine. So anyway, the way we had this was fine. We're gonna sort our list, and we're gonna turn so again I want to make word an empty list for now, just so that it stops complaining. unused function argument. Alright, extended. Okay. Then we will sort the signs but never used. Yeah, I will use it. So now we will after we sorted our list. Why did I do that? What was my thinking? Hectic. I want to take our word. So if word dot index, okay, is smaller than middle, for word smaller than middle, okay, I would, if word in list return true, let's say unexpected. Expected in all. And say while, wow, false, list, okay, Oh, silly. It's more like an if statement. If word and index is smaller than else, can you do an else else if word else if else if um, something more word in word range mm, this is hard. This is not working because what if the word is, what's the index got to do with it? Dividing the book in half. Um, and it's sorting it in alphabetical order. I mean, I get it, but and we made progress because I can see we've put in 2 arguments here. So we actually don't need 2 functions like I was stressing about. Um, what if we said new list equals list equals middle index, middle index. Okay, we're just going to return that plus plus our word, okay? And what we will do is we will then new list dot sort. We'll then sort it in alphabetical order. And then what? I'm trying to see if it comes before or after. So if it's before, then the list shouldn't change. Dot append. If we're using dot append, it's like if it's in what instance would it change if we sorted it? Well, I would think if it is after, in terms of alphabetical or after the middle, doesn't change. So it's only if the sorting results in a changed list that we know that it needs to search before middle. But you know what? I think there's a bit of slicing here that we're missing. And why don't we try that? Why don't we try some slicing? Let's try a different approach. Because we can actually create a new list using slicing, correct? So we've sorted our list, right? We know what at least our middle is. So we can create two lists. I think I figured it out. We can create two lists, one for before and after. So we will say, now that we have sorted it, we can try the following. We can try first half equals list, and then we will specify. So it will start at 0, okay, and it will stop at middle. Okay? And then the second half will equal list, right, from middle, and that's it. And just leave it empty. So let's try, and let's see if we say return first half and return second half. So I don't think we're on the free version, so second half. I know we haven't chosen index yet, but let's see if we get two new lists. Alright, so now we need to just put in or run our function. So print in bisect. For now, I'm just going to take out word. Okay. But we'll put it back. Apple, banana, cat, dog, giraffe, horse, monkey, zebra. So we are getting somewhere. Yay! So we've managed to split our list into two. I'm going to put our second argument back in. And now I think it's quite easy. So it's an if-else statement. So if word in first half, okay, return true, if word in second half, so then check if it's in the second half, return word second half, I don't know, return true, else return false. Word else print word not in list. You think this is gonna work? So now let's try with dog. So we can now enter in branches. What was the question? Right, that turns true. Yeah, we could do that. We could say or second half, then return true, else print word not list. So else. It's just measurable with the. So we don't use middle index. So yeah, anyway. So now we can print in bisect. Our list is called dictionary. And now we can look for any word we want. So let's try giraffe. And let's see what we get. True. Let's try bunny. True. There's no bunny. Oh, goodness. Or word in second half. Let's try now. Should be false. Word not in list. Fantastic. We did it. I think we did it. So I can delete this. Oh, what a challenge. So all we had to do was use our slicing to split the list into two. And then you just use your if else statement. If word in first half or word in second half. That is amazing. Very tough. Should we try? We have cat. Oopsie. Cat. Yeah, we do. So it should be true. We could also, if we wanted to just be a bit more specific, right? we could say word found in first half of list. I'll let word in second half. Word found in second half of the list. I'll print. So you know I want to do that. I want to make sure our code's working. So we know in this case it should be in the first half cat. So I want to see it actually say that. Word found in first half of the list. So the way I understand it then, the code is working as it should. So it saves itself time by only having to check half the list of words initially, and only if it's not there will it then resort to the second half. If we read the question, it was, you start in the middle and check to see whether the word you're looking for comes before the word in the middle. If so, you search the first half of the list. I'm quite happy with that. Let's take our usual short 10-minute break. We're nearly on an hour. And then we'll move on to exercise 11 and 12. And then we can mark this little section as complete. We're not even done yet. So, but this is great. We've done 12 exercises. I'll see you guys in about 10 minutes.
That show.
That's fine, bro. You're the person that we make fun of. We take you and we take your chart and we make fun of it. We put the two charts next to each other and we cuckold you and we say, look, we're banging the mad games.
Currency. Collectively, central banks are working to issue in a new system, and that means destroying the purchasing power of the currency and bringing down an entire class of people with it.
Characterize Bitcoin as a digital currency. You can call it digital gold. You can call it digital cash. You can think of it as digital money. You can think of it as digital property. You can think of it as digital capital. You can think of it as digital energy. You can think of it as a digital asset.
Government could just stop Bitcoin tomorrow. Liberty Reserve was shut down across 42 countries. Bitcoin can be like that, tomorrow banned. The way that they shut Liberty Reserve down was the Americans issued a financial services order. Anyone who took Liberty Reserve was banned from the banking system anywhere on earth. Basically, it means your whole company's wiped off the face of the earth. And they could do that. And they can do that to Bitcoin right now.
This is fine.
back. Our next exercise looks equally as challenging. So exercise 11. Two words are a reverse pair if each is the reverse of the other. Write a program that finds all the reverse pairs in the word list. Now, I'm not aware of a sort of reverse method, but if a word is the reverse of the other, my understanding is that they have exactly the same letters. They're just inverted, right? So I would think then that we need to take a word, right, from a list, and we need to break it down into letters and then compare to see if any of the letters in any of the words are the same. The problem is that when we use list to basically create letters, if I'm not mistaken, it makes a new list. So we're going to have lists within lists. So it's going to be interesting to see how this actually works, but let's give it a go. So we're going to keep our dictionary list over here, but maybe we should add some reverse words. So like we had tap and we had pat, and then let's keep the rest. Maybe we can add pats further down the list. So that is basically a reverse word, but it's not a, actually it's not a, what do you call it? A anagram. It's not an anagram. Two words are a reverse pair. Each is the reverse of the other. So I don't think jumbling up the letters is going to help, because it could be an anagram, but that doesn't necessarily mean that there are a reverse word. So I'm thinking, first of all, in order for it to be a reverse, the length needs to be the same, right? So function for reverse pairs. Okay, we're going to have our list, and I think that's it. Now, for word in list, for word in we want to iterate, I suppose, len list, right? For every word, oh, it's already telling us dot reverse. Is dot reverse a method in Python? Oh boy. ChatGPT's doing its usual story. Let me check on art. Excuse me. Let me check on Aria. Dot reverse is a method in Python that reverses the order of elements in a list. When you call this method on a list, it will reverse the elements in place, meaning it will modify the original list without creating a new one. So try this code, but I don't know. I don't know if it's gonna work. Let's just say prints verse pairs dictionary. Let's see what happens. Yeah, because we want to say word dot split. It is no. We don't really want to split the word, do we? Let's take split word. Sorry, list word. Argument type int cannot be assigned to parameter. What if we said return? Still doesn't work. List word. Word in range. We want to split. So we can say new word equals split word. Sorry, list. Yes. Word. This is a hard one. Write a program. So I'm going to ask ChatGPT for help. Can you help with this exercise in the outline? But on the so side, the first thing we do is we convert the word list to a set called word set. I don't understand why we do that. Still busy. Use include set. I thought set remove duplications. So I still don't understand. Checking if an item exists in a set is on average, whereas checking for we are not concerned about, rather we are using the set. It'd still work if we didn't use set. Yes. So we would, because I don't understand why they're using sets, we would create a function with a single input, which is basically our string. In that, we're going to create a new list called reverse pairs. Then for word in word list, reverse word equals word. And then I see here we've got some slicing going on. If reverse word in list, so does it really explain that? Not really. Create a set of words. Yeah. Iterate through the list of words, and for each word, check if its reverse is in the set. What does this mean? It's a slicing operation that reverses the string word. So we are using -1, which starts as omitted. So it starts the beginning at the string, stop is omitted. So it defaults to the end. Step is -1, which means the slice will take every character from the string in reverse order. I understand. Now I understand. So basically we create a reverse, we reverse it by taking the word, and when we slice it in this manner, we're basically putting it in reverse. And now then all we do is check if the reverse word is in the list. And then they've added this as well to avoid, I don't know, there's a reason, but we don't need to add that. We can try and code that ourselves, reverse pairs list, so we can say reverse word. Okay, so for word in list. I think was how ChatGPT did it. For word in list, we will create a new word called reverse word, and that reverse word will equal word, and this is basically to spell it backwards. So we're just going to leave it blank and put that as negative. Now then we say if reverse word in list return true. What was the question? Write a program that finds, I would just say return word, return reverse word. Now why is it so miserable? Reverse word is possibly unbound. I don't know. So now we can say reverse pairs dictionary. Seems like we're going to get an error. Tap. That is correct. So it works. We can also try with the list that ChatGPT came with, both which is kind of handy. They all basically reverse words. Stop, pots, all of these words. And let's paste them in here. Now, if we should get a couple of words. And I think our problem here is our indentation. So let's try that again. And now we should get more words. Continue. No, it won't let us. We do have to create an empty list. So let's call it new list. Okay. And then we will say new list dot append word. And then we will end off by returning return new list. So now we should get a list of the words. And we do. basically all the words. But if we add like a random word like, yeah, silent, then silent shouldn't feature at all. Okay, you see it stopped at stressed. And it removed rat because we replaced rat with, you see the car. So it removed rat and it also didn't include silent. Okay, so that's how we reverse a word. Exercise 12. Two words interlock if taking alternating letters from each forms a new word. For example, shoe and cold. Interlock to form schooled. Write a program that finds all pairs of words that interlock. Don't enumerate all pairs. Can you find any words that are three-way interlock? That is, every third letter forms a word, starting from the first, second, or third. What I don't understand is how Python would know it's a new word, not just some random, like, you know, could just mix up the letters and that's that. So how would Python know it's, what is the word? Interlocking an actual English word, and that does jumble some letters. In this question, paste and enter. So it says here that to solve the problem of finding interlocking words without enumerating all pairs, we can use a dictionary to allow efficient lookups. For two words to interlock, taking alternating letters from each should form a valid word. For example, shoe and cold interlock to form schooled. Shoe provides the letters at positions 0, 2, 4, 6, and so on. Read the list of words into a set for efficient lookups. Then we're going to generate potential interlocked words by alternating letters from two words, and then check if the generated word exists in the set. So with open words text as F, no, this looks a bit out of our league. I think you'll agree with me. Some of these are, not for the faint-hearted. Some of these exercises, they don't seem to be all of them for beginners, which is not a bad thing. It's good to challenge ourselves. I'm not going to get hung up on it though, which means we are done, or it looks like, with indexing, but it doesn't seem, I'm on the wrong, it signed me out. Let me just switch here. So we sign back in. Can now mark indexing as completed, which is awesome. And by the way, keep an eye out because there's going to be some exercises. I found a great place, also free to learn. It's got free exercises. So, you know, learning is not just about knowing the theory and understanding, but it's actually applying what you learn. So I'm thinking of doing some of these, because the more of these that we do, and they don't look hard. I mean, some of them look a bit difficult, but the more of these that we do, the more comfortable we're going to get coding. So we'll be going into that sometime. Not again that I'm trying to drag this out, but you know what? We have to apply what we're learning. So let's just see here. I've taken some medicine, so I'm a little bit on the drowsy side. I don't even feel like we're halfway. And it's been how many hours? I agree. Let's just go to unit 4. 6 hours. Yeah. So we've done 4.1. We've done lists. We've done indexing. Now it's slicing. So let's have a read through slicing. So it is often the case that a program requires referencing a group of elements within a list, instead of a single element using a single value of the index. This can be accomplished by slicing. Consider running this example. So we have X, which is this list over here of numbers. We can print X, or we can print 0 through to 9. Let's see what happens. Nothing. Let's see. 0, 1, 2, 3, 5, 6, 7, 8. Let's just try change it because there's more than 9. So let's try 5. And then it should print a shorter list. Yeah. The colon operator can be used to index multiple elements with the list. Index on the left side of the colon is the starting index. By Python's indexing convention, the value on the right side of the colon indexes that value minus 1. Okay, so be careful with the right index. Since the variable x has 9 elements indexed from 0 to 8, effectively references all indices from 0 to 8. And you should be careful when using the right index, since Python will sequence up to that value minus 1. For the sake of convenience, there are also shorthand slicing techniques that do not require specifying the start or ending index when it's assumed the complete rest of the list is being referenced. So this is just revision. We're just going to read through it. In addition to specifying the start and stop indices, you can also specify the step. Here is an example that will count by 2s from elements 3 to elements 7. Okay, remember it's 8, but it's going to stop at 7. Every other element starting at index 3. The step size is given by the index value after the second colon. Finally, Python allows for negative indices, where by convention, the index -1 implies starting from the end of the list. In these examples, the step size of -1 means to count backwards in steps of -1. And then I see there's a video. So let's just do a bit of further reading there. Unless it's a duplication, which it is, so we can mark it as complete. You can watch the video, of course, if you'd like. You'll find everything here on the learn.saylor.org website. Now we on to list methods. So list methods, I see we can also complete it. Let's see if we can get to 4.2 by the end of this video. So practice these examples using Replit to become more familiar with some methods commonly applied to lists. As you go through these examples, you should begin to see how powerful Python can be as a programming language. Python has a great built-in list type named list. List literals are written within square brackets. Lists work similar to strings. Use the len function and square brackets to access data, with the first element at index 0. Yeah, okay, so we know how to do this. And I see colors. Yeah, we've done all of this. An assignment with an equal on list does not make a copy. Instead, assignment makes the two variables point to the one list in memory. So, for example, B equals colors does not copy the list, okay? The empty list is just an empty pair of brackets. The plus works to append two lists. So if we have a list of 1 and 2, and we say plus another list of 3 and 4, we'll get a new list of 1, 2, 3, 4. Python's for and in constructs are extremely useful, and the first use of them we'll see is with lists. The for construct, for var in list, is an easy way to look at each element in a list. That's right, do not add or remove from the list during iteration. So it's actually nice, we did the practical, which was the exercises, and we did struggle on some of them a little bit, but some of them we came right. And now we're going over the theory, and it's actually making sense now, right? Sometimes you read the theory first and you think you understand it till you try and do it. If you know what sort of thing is in the list, use a variable name in the loop that captures that information, such as num or name or URL. Since Python code does not have other syntax to remind you of types, your variable names are a key way for you to keep straight what is going on. The in construct on its own is an easy way to test if an element appears in a list. Value in collection tests if the value is in the collection, returning true or false. The for in constructs are very commonly used in Python code and work on data type other than lists. So you should just memorize their syntax. You may have habits from other languages where you manually start iterating over a collection, where in Python you just use for in. You can also use for in to work on a string. The string acts like a list of its characters, I presume. So for ch in s prints ch, prints all the chars in a string. Okay. The range function yields the numbers 0, 1, and so on. And range a, b returns a plus 1. The combination of the for loop and the range function allow you to build a traditional numeric for loop. So we're also used to working, we're used to working with range by now. There is a variant X-range which avoids the cost of building the whole list for performance-sensitive cases. Python also has the standard while loop, and the break and continue statements work as in C++ and Java, altering the course of the innermost loop. The above for-in loop solves the common case of iterating over every element in a list, but the while loop gives you total control over the index numbers. Here's a while loop which accesses every third element in a list. So we initialize I to 0 and we say while I is smaller than the length of A, print AI, which is prints the element value, the index value, and then I equals I plus 3. So you'll keep printing the third value basically because you're adding 3 before the loop runs again. Here are some other common list methods. List.append adds a single element to the end of the list. Note, it does not return a new list, it just modifies the original. If you want to create or return a new list, you should use plus to concatenate the lists and not .append. List.insert, where basically in your brackets you can put the index number where you want to insert and then whatever the value is that you want to insert. So it inserts the elements at the given index, shifting elements to the right. List.extend adds the elements in list 2 to the end of the list. Using plus or plus equals on a list is similar to using extend. List.index brackets element searches for the given element from the start of the list and returns its index. Throws a value error if the element does not appear. Use in to check without a value error. List.remove element searches for the first instance of the given element and removes it. List.sort sorts the list in place, but note it does not return it. Okay. List.reverse reverses the list in place, but it also does not return it. And list.pop, and then in brackets you specify your index, or you can leave it empty, in which case it will default to the end or the last element. It returns and it removes and returns the elements at the given index. It returns the rightmost elements if index is omitted. Notice that these are methods on a list object, while len is a function that takes the list as an argument. One common pattern is to start a list as an empty list, then use append or extend to add elements to it. Slices work on lists just as with strings and can also be used to change subparts of the list. So we have we know how to do that. So I'm going to mark that as complete. And remember when we used slicing, that tricky exercise we were doing at the beginning of today's video, we were able to at least assign a variable to our new list by slicing. Okay, I see we are still on 4.1. Indexing, slicing, list methods is done, and then it's just list comprehension. So I am going to end the video, but in the next video we will continue with list methods and list comprehension. I hope you are finding it insightful and rewarding so far. If you have made it this far, don't forget to tap yourself on the back. Props to you. I will see you in the next video. God bless.